Now we'll talk about resistors in series and resistors in parallel, and we'll start off with resistors in series. If you take three resistors and you connect them with a wire, and they're all connected in a row like this, that's series. So let's put them connected to a battery here. So these three resistors are connected in series. The point here is that there's no branching. The current never divides. There's only one path through which it can flow. The resistors are said to be connected in series. Now take a look at this picture. There are three diagrams here. This one on the left shows three resistors connected in series, and they're named R1, R2, and R3. And this picture in the middle shows a pump that pumps some water up to the top of this system of three water wheels here, and the water flows down here and causes these water wheels to turn and then ends up back down here in this reservoir. And then on the right here we have this building, and the elevator takes people up to the top of the building, and then the people come down the stairs and the ladder and the pole there. Now these three diagrams all have some important similarities. Notice the flow in each case. There are electrons flowing around the circuit, and the electrons go through resistor 1, and then they go through resistor 2, and then they go through resistor 3. In the same way, the water gets pumped up to the top here, and it comes down through water wheel 1, and then through water wheel 2, and then through water wheel 3. And the people, they ride the elevator up to the top, and then they come down the stairs, and then they come down this ladder, and then they slide down this pole and go back around. In all three cases, there's only one path through which the electrons or the water or the people move. So we can say that this hydraulic system here is analogous to this electrical system in that way. And this system here with these people moving through the building is also analogous to the other two. And the point to note here is the concept or some of the concepts of resistors in series. In series, you should note that first, let's take a look at the hydraulic system. Every gallon of water that flows through water wheel 1 also ends up going through water wheel 2, and then also through water wheel 3, and it's the same water, but the amount of water through each of those water wheels is the same. And look over here at the building. All the people, there's only one path for them to follow, and all the people that go down the stairs also come down here and go down the ladder, and then come down here and slide down the pole. That's the only way back down. And so then they ride the elevator back up to the top. But there's only one path, and it's the same people that go down the stairs, and then the ladder, and then the pole. But if you were to count the number of people going down each one, they would be the same for each of these. The flow of people through the stairs, like the number per hour for each of those three things, is the same. And then over here in the electrical circuit, the number of electrons in a given minute or in a given second going through resistor 1 is the same as that through resistor 2 and that through resistor 3. And they're the same electrons. And the rate of flow through each of these resistors is the same. In other words, the current is the same in all three of those resistors. And it has to be that way because those resistors are in series. So in your notes you can write this. For resistors in series, the same current passes through each resistor. The same current passes through each resistor. And that's a fact that should make sense to you. You can memorize that fact, and you should, but far better than memorizing it would be to understand it. That idea should make sense if you understand the concept of series. This idea that the same current passes through each resistor can be written mathematically like this. I, the current coming out of the battery, that's what we would call this current right here, coming out of the battery, current I. That's going to equal I1, and that's going to equal I2, and that's going to equal I3. And I1 would be the current flowing through resistor 1. I2 would be the current flowing through resistor 2, and I3 would be the current flowing through resistor 3. And all three of those have to be the same. Every electron that comes out of the battery goes through resistor 1, and then through resistor 2, and then through resistor 3. So for three resistors in series, the same current passes through each resistor. And you should also understand that that concept will apply to two resistors in series, or four resistors in series, or 5, or 100, or 1,000. If things are in series, the current through each of those things will be the same.